n by m grid of squares. Each square contains a number ai. The cost to travel through that square. You're starting at the most top left square. Okay, so you're starting at top left square. At each turn, you may choose to move down or right, but not both. At the minimum cost, it would take you to travel to the most bottom right square. Okay, so top left to bottom right. Move down or right. Okay. Alright. So from 3 to 2. What is it? We can take the path 3 to 1, 1 to 2. Okay. Down to, okay, let's go come up 18. Okay. For like dynamic programming. Let's see. Uh, uh, main dm.tie no PDR. Okay. Next, do the minimum cost. So it's gonna be, I think it's dynamic programming. That's all it feels like. It's a 3 by 4 grid. Yeah. Okay. So constant. How big is n? And how big are they? They're 500. Okay. So then we'll have a grid, and with the grid, and then we'll just have like the actual DP. It's a table. So we'll read in n, m, then first go through all of n, go through all of m. Okay. Okay. So all right. What did I do? So read in grid ij. We'll pretty much do the same thing. Okay. So dp ij. That's just the minimum. Unless you want to be the maximum. So I guess we'll just say memset now we'll just say and dp well, you could either go down or you can go right. -1 j, so this is going from down. This is going down. That's going down. Or you could be going sorry, what else could you do? Or you could be going right. And of course the base case will be dp 1 1 equals 0. At this point we just output dp and m. Okay, let's see. Hopefully I didn't make any silly errors anywhere. The idea is simple. Let's see. What, 0? Let's compare. Oh, plus 1, plus 1, plus 1. Plus 1. Plus 1. That should be right, I think. 5? No. Oh, yeah, the values. That's great, actually. And that means this is not 0, it's actually grid 1 1. 18. Okay, simple. Let's submit that. Okay. There we go. Simple.